Let's try one more practice problem before you take a look at some problems on your own. In this situation, we are told that we have a 95-kilogram running back making a turn on the field while running. He makes a quarter of a turn in 2.1 seconds. The radius of the circular path is 12 meters. We need to determine the velocity of the running back, his acceleration, and the centripetal force on the running back. So let's first take a look at this. We need to determine the velocity. Now, we had earlier said that velocity for a full turn was going to be 2 pi r all over the time it took to go around the entire circle. Now, since this time he's only going a quarter of the way around, this takes 2.1 seconds, we know that his full time, or his period, would really equal 4 times 2.1 seconds, or something equal to 8.4 seconds. So finding the velocity shouldn't be that bad. We'll come over here, we'll say that velocity is equal to 2 times pi times our radius, which is 12 meters, and then we simply will divide by 8.4 seconds. In doing this, we should find that the velocity of our running back is simply going to equal 8.97 meters per second. Now, since we know both the period and the velocity, we could use either of our centripetal force equations. However, to make sure that we're practicing our new one, I'm going to go through and solve for his force by using the equation we just finished discussing. The idea that force centripetal equals mass times velocity squared all over r. So now I'll plug in. I'm trying to find his force. I know he has a mass of 95 kilograms. We know he has a velocity of 8.97 meters per second. We have to make sure we remember to square that. And then we'll divide by the radius, which is our 12 meters. If we go through and calculate all of this, we will find that the centripetal force is simply equal to 637 newtons. The last part asks us to solve for his acceleration. Now, we haven't really discussed a lot of information about centripetal acceleration. We know it exists because our running back is changing directions as he makes the turn. But that's about all we know so far. But let me ask you this. Force equals, and everyone should be filling in their head, mass times acceleration. That's something that we learned at the very beginning of our discussion of forces. So using this, we know what the force on our running back is. We know what the mass of our running back is, so we will be able to solve for the acceleration. So I'm going to plug in my centripetal force of 637 newtons. I know that his mass is 95 kilograms. And I want to solve for acceleration. The acceleration of my running back will simply end up equaling 6.71 meters per second squared. Using this information and these practice problems, you guys should now take a look at the interactive physics questions that you will be working with. In problem 1, it's good to note that the frictional force is what's causing the centripetal force. So when you determine what the centripetal force is, you'll set that equal to frictional force. Hopefully that little hint will help you go through. Additionally, in problem 2, the tension in the string is going to equal the centripetal force. So set those equal once you solve. And then you'll be dealing with Tarzan. Good luck and enjoy.